Hey y'all, this is Ms. Hatch with Help with Online Math, and today we're working on simplifying radical expressions. This is part two of a continuation of our series on that. I'm going to give you a second to write down those examples and we'll get started. Hang on. First example, I want you to keep one thing in mind. I have to work with radicals and consider them just like I would polynomials. And when I'm adding or subtracting polynomials, I have to deal with like terms. I don't know why my pen is doing this, so hold tight one second, y'all. Sometimes it gets a little wonky. There it goes. Okay, it might appear again. So I got to deal with like, oops, there we go. Thank you. Like terms. All right. So when I'm dealing with polynomials and I have like terms, I have to have the same variables and they have to have the same degree on the exponents. Okay. With radical expressions, I have to have the same index. Okay. This is the index, the number that's here. And it's if it's not here, it's an understood two. And I also have to have the same number under the radical called the radicand. So you see in this case, both of these have an index of 2 and I have the same number under the radical. That means I can combine the like terms. Now, when I combine them, just like I do with polynomials, I'll be either adding or subtracting the numbers that are in front of the radical expression. So this has an understood little 1 here. This has a 5 here. They're also considered coefficients and they're called coefficients. So I'll add 1 plus 5 and that'll give me 6 square root of 3. Notice I didn't multiply these because I'm adding. I'm combining the like terms and I'm done right here. Now in this particular example, if you look at it, I actually have a square root that I can evaluate because the square root of 9 is 3 and the square root of 16 is 4. So I'm going to simplify it by first evaluating those radicals. So I have 2 times 3 plus 4. So that's 6 plus 4, and that's 10. And that's as far as I can go. Now, this one looks a little different. If you notice, I have the same index. That's all cool and everything, but I don't have the same number underneath the radical. So that means I've got to simplify it so that I do have the same number under the radical. So what I'm going to do is I'm going to break down 48. And you always want to think of what's a perfect square root that is a factor of 48. Okay. We can do our other method that I've shown you in other videos, but think of what is a square root what is a factor of 48 that's a perfect square root. So that's 16. Same thing for 27. It's 9 and 3. Okay. Now, what's going to happen is 16 is a perfect square root, so I can evaluate it and pull it out and multiply it by my coefficient of 2, and 3 stays underneath the radical. Coming over here, 9 has a perfect square root. I'm going to pull it out, say 3 times 3, square root of 3. Okay? Now I need to evaluate this. 8 square root of 3 minus 3 times 3 is 9 square root of 3. Now remember, I am combining, meaning I add or subtract according to the rules of integers, my coefficients, my numbers in front of the radical. So that'd be negative 1 square root of 3. And stick a fork in me, I'm done with that one. All right? Ready for another example? Hold tight. I'm going to show you another type. Same process though. All right, let's go to another example involving square roots and evaluating square roots. And in this particular example, I have 2 square root of 50 plus 12 square root of 8. My indices are the same. They're understood 2, but I don't have the same thing under the radical. So that means I need to break this down. So think of 50. What is a number that's a perfect square root? That's a factor of 50, okay? So that would be 25. 25 times 2. Perfect. All right. Rewrite the other one. Same thing. What is a factor of 8? That's a perfect square root. That's 4 times 2. Alrighty. So now, since 25 is a perfect square root, I can pull it out, evaluate that root, and gives me 2 times 5, square root of 2 plus 12 times 2, square root of 2, because that's the square root of 4. Then I'm going to multiply to get my coefficients simplified here. Same thing here. And I'm going to combine those two, and that'll give me 34 square root of 2. Are you tracking with me? So far, so good? Perfect. Let's do another example, this time with some cube roots. Okay? Hold tight, and I'll show you that one. All right, let's look at example 5. This time I have the cube root of 16 plus 3 times the cube root of 54. So always think of what number that's a factor of 16 that might have a cube root. Remember, a cube root means it has the same number being multiplied 3 times. Well, we're going to figure that out, and we know that it's got to be 8. So I'm going to break 16 down into 8 times 2. And I'm going to rewrite 3 cube root of, and I'm going to do the same thing for 54. So that would be 27. Okay. There are certain numbers you're going to learn to memorize and think of that have cubes, and that's 8 and 27 and on like that. Okay. So now I'm going to take the cube root of 8, which is 2, cube root of 2, plus 3, and the cube root of 27 is 3 times the cube root of 2. Alrighty, just rewrite that one. I'm going to try to write it so it's not so messy. Plus 9 cube root of 2. Now, I can add or subtract my coefficients, my numbers in front of the radical. So that'll be 11 times the cube root of 2. And stick a fork in me. We're done with that. I can't go any further because chances are you'll want an exact answer, and that's what you want to leave it as. If you go any further, it's not going to be an exact answer. Now, let's do another one where we have a few variable expressions. Hold on. Okay, now we've got a problem that has some variables involved, but we're still going to do the same process. So since my index here is 2, remember when we don't see it, it's an understood 2, I'm going to evaluate and take the square root of 49. So the square root of 49 will be 7. So I'm going to put that outside the radical, and underneath the radical, the x is going to stay because it doesn't have 2 x's, so I can't evaluate it any further. Over here, I've got 14 as my coefficient. And what's the square root of 100? Well, that's 10. Okay, so I'm going to go ahead and say that's 56. Square root of x minus 140. Square root of x. And then we can subtract those two. 140 minus 56. So that's going to give me a negative. I think I can squeeze it over here. Let me see if I can do that. A negative 84 square root of x. Yes, I can fit it in there. Okay, perfect. All right, you got that one? Let's do another example. And this time we're going to have some more variable expressions. All right, hold tight. All right, let's look at this problem. This time we have some more variables here, and looking at what's underneath our radical, I can take the square root of x squared in both cases, but I've got to simplify this so that I see if I have some like terms. Because right now I've got a 48 and a 75, and we know these have to be the same number where I can do any combining. So let's go here, and we know that 48 does have a perfect square root, and that's going to be 16. So we have 16 times 3 x squared plus 7. Now 75 has a perfect square root. It's 25 times 3 x squared. Y'all can see how this is shaking out, don't you? So I'm going to do take the square root of 16, which would be 4. And then I can take the square root of x squared, which is x. And underneath the radical, that's just going to leave me with just plain old 3 plus 7 times 5. Oops, I forgot to put my x, y'all. Let me undo that. 7 times 5 and my x, because x squared, square root of x squared is x. And I'll put the square root of 3, okay? Now that's going to give me negative 12x, square root of 3, plus 35x, square root of 3. So we now have the same indices, same index, same numbers under the radical. So that means I can now subtract my coefficients. So 35 minus 12, that's going to be what? 23? X square root of 3. And that's it. Stick a fork in me. I'm done. Follow me for more help with online math. And I'm Miss Hatch.